This video is about the negative identities of our three basic trig functions for now: sine, cosine, and tangent. And we're going to use our full unit circle to discover these. As you can see now on this picture is a full unit circle with all of our special arc lengths and terminal points plotted and coordinates labeled, giving us the x and y coordinate of each terminal location, which of course give us the cosine and sine values of those arc lengths. And I'm going to use just one example to get this illustrated here. Let's say we start from our initial point of 1, 0, and I'm going to trace one of these inner circles to make this clear. If we extend an arc in the counterclockwise direction, and I'll take this one pi over 3 so that it ends up at the terminal location for pi over 3, we can identify the cosine of pi over 3 by the x-coordinate of that terminal point. So the x-coordinate being 1/2 means that the cosine of pi over 3 is equal to positive 1/2. Now, let's take another arc in the opposite direction. So again, starting from the usual initial point, I'm going to extend an arc negative pi over 3. And so, though the same distance, it's now in a clockwise direction, which makes it a negative arc length value. And notice that the cosine at that terminal point, which is now negative pi over 3, is, as you can see in the x-coordinate of this terminal point, positive 1/2, which is, of course, the same as it was above. So we can say the cosine of negative pi over 3 is also 1/2. Now, this hopefully makes sense given all the symmetry we've been understanding about this unit circle. In fact, you can draw the line of symmetry straight from the top point down to the bottom one. So I'm drawing a dashed line from the terminal point for the arc pi over 3 on top, straight down vertically to the terminal point for negative pi over 3 on the bottom, which is, by the way, shared by the terminal point for positive 5 pi over 3, which you can see labeled here. So the symmetry illustrated by this vertical line connecting those two terminal points reminds us, hopefully, that those points should have the same x-coordinate, and of course the x-coordinate is the cosine value, and what do you know, they match. So that's just one example. You could create many more pairs of these symmetric, similar values for cosine going at various arcs around this circle. The result that we could summarize would be as follows. We could say that the cosine of the negative value of some arc x would be equal to the cosine of the positive arc value x. So this is illustrated here by these two different colored arcs, one being the cosine of positive pi over 3, giving us a value of 1/2, and then one being the cosine of negative pi over 3, also giving us a value of 1/2. So this little equation, namely the cosine of negative x is equal to the cosine of positive x, ends up being the negative identity for cosine. Let's now explore the negative identity of sine. And so we'll go back to the same example we did for cosine, which is, let's extend an arc positive pi over 3, so starting at initial point 1, 0, let's extend to the positive pi over 3 location, where the terminal point is listed as 1/2 comma root 3 over 2. And based on our understanding of sine and cosine, we know that the sine of pi over 3, which is that arc we just extended, is the y-coordinate of that terminal point. So that would be, of course, positive root 3 over 2. Let's now extend a negative arc the same length. Starting at initial point, let's extend it negative pi over 3, which is the same distance but in the clockwise direction. So I'll end at the same terminal point, as you can see down in quadrant 4 here, as 5 pi over 3. And we know, again, based on our understanding of the unit circle, that the sine of this arc, which I'll write here, so the sine of negative pi over 3 would be equal to, well, the y-coordinate of that terminal point, which is negative root 3 over 2. We could summarize the negative identity for sine in the following way. We can say that the sine of negative x must be equal to the opposite or negative sine of positive x. Let me go back and use the same colors I used below to highlight this identity general property here. So x is our arc length, and the sine of negative x would be the one I wrote in green down here. X being pi over 3, so negative x would be like negative pi over 3. All right, and the result of that, the sine of that we said earlier here was negative root 3 over 2, which is the opposite of what it was for sine of positive pi over 3. So as you can see, the sine of the negative arc is the opposite of the sine of the positive arc x, which we have listed here as root 3 over 2. Now, this is all utilizing the symmetry of the unit circle, so hopefully this continues to sink in as we identify all these helpful tricks with it. Let's now explore the negative identity of the tangent function. As you can see around the unit circle, I have written in our special arc tangent values. We've discussed these earlier, and they usually don't fit on the unit circle because of how much stuff we have on it already, but they come from the coordinates for sine and cosine of each coordinate. And remember, tangent is sine divided by cosine. So let's use the same example we've done before to make this familiar. I'm going to extend the arc positive pi over 3, so starting at initial point 1, 0, extending to pi over 3. And as you can see written in here, that means our tangent value is square root of 3. Now let's extend the negative version of this arc, namely negative pi over 3. We can see here that the terminal place for that arc has a tangent value of negative root 3. So extending an arc in the negative direction, which is clockwise, from 1, 0 all the way through to the terminal point here located at negative pi over 3, which is shared with positive 5 pi over 3, gives us a tangent value of negative root 3. Let's again identify the symmetry here. So we can say from this that the tangent of pi over 3 is equal to the square root of 3, and the tangent of negative pi over 3 gives us a tangent value of negative root 3. So once again, a lot like the sine function, we're finding that with opposite inputs, namely positive pi over 3 and negative pi over 3, we're getting opposite signed values, positive root 3, negative root 3. This gives us a negative identity for tangent in the following way. The tangent of negative x would be equal to the opposite or negative of the tangent of positive x. Let's take a moment now to apply these negative identities we've discussed. So in the upper left corner, I have them written, namely cosine of negative x is equal to cosine of x, sine of negative x is equal to negative sine of x, and tangent of negative x is equal to the negative tangent of x. There'll be more to discuss with those properties when we get to the graphs of these functions, but for now I just want to look at these couple examples listed. So the first over here being, what is the cosine of negative 7 pi over 6? Now, if you're getting good with the unit circle, it doesn't take much to find that answer as the x-coordinate of the arc of length negative 7 pi over 6. But let's see if we can apply the symmetry to this. If the cosine of negative 7 pi over 6 is what we want, and we know the identity for cosine is that when you input a negative x input arc, the output is no different than if it were a positive input arc, we can say that the cosine of negative 7 pi over 6 would be equal to the cosine of positive 7 pi over 6. So that's just a direct use of this negative identity formula. And of course, we know the unit circle well enough now to know that the cosine of 7 pi over 6 would be negative root 3 over 2. So there's an application of the negative identity for cosine to be able to evaluate an expression given here. Now, let's take a look at this next one, which is asking, what is the cotangent of negative x equal to? It doesn't take much observation to look back at our identities listed here in the box to see that there is no cotangent negative identity listed. But let's see if we can figure it out, because we know what cotangent is at this point. Cotangent is cosine over sine, so we use the same input, meaning cotangent of negative x would be cosine of negative x over the sine of negative x. And now we can use the negative identities we know for sine and cosine to write an equivalent form here. So cosine of negative x we know is equal to cosine of x. There's one identity. And sine of negative x is equal to negative sine of x. There's another identity we know. So now let's just do a little simplifying of this fraction. If we have a positive over a negative, the whole result could be written as negative cosine of x over sine of x, which of course is negative cotangent of x. Right? This fraction is cotangent, cosine over sine, and there's negative sign in front of it. So if we connect the beginning and end here, we'll see that the cotangent of negative x where we started is equal to negative cotangent of x where we ended. Now, just a little question here. Does that appear to act more like the cosine negative identity or the sine and tangent negative identities?